very good day to all of you. I am Palingu Ratnasinghe. I will be presenting my poster presentation for final year project 1. I would like to thank my supervisor, Dr. Kelvin, for supporting and guiding me through this. My topic will be on preservation of Sarawak shoreline using breakwater. As a start, coastal areas are considered the most productive and valuable ecosystems on Earth. A coastal area portrays a significant role in the combination of economic and demographic occurrences. These areas supply food, transport, recreation, and energy livelihood to the residents. The equilibrium and the long-term sustainability of these areas have fragmented due to climate change, global warming, and the fleeting escalation of development projects. Coastal area erosion is one of the major issues faced as a result of that. The coastline in Sarawak experiences erosion and has been getting more severe lately. 17% of the Sarawak coastline is currently eroding, and because of this, an average ocean level rising of 0.7 millimeters annually occurs, thus creating threats to infrastructure constructed along the Sarawak shoreline. The Department of Irrigation and Drainage have adopted methods like geotextile tubes, sea walls to protect the shoreline. However, there is a lack of convenient design for the breakwater along the Sarawak shoreline. Now let's look at the research questions and objectives we are aiming for. For the research questions, the first one is, what is the appropriate design type of breakwater that can stop the waves at a maximum height? Breakwaters are identified to reduce the effects of a storm surge or shoreline erosion with their productive methodology. They captivate high tidal energy during storm events, so the correct selection of breakwater type will make the preservation process reliable. The next one, sustainability and validation with changing marine environment and geotechnical conditions. The environment changes with time. Therefore, a feasibility study regarding the structure changing environment is very important to be conducted. For the objectives, to determine the appropriate breakwater template for 7 different regions along the Sarawak shoreline, and there's another one to identify the function of breakwater and the process of preservation of Sarawak shoreline. Now let's move on to the literature review. The length of the coastline of Malaysia is approximately 4,810 kilometers and 1,235 kilometers east from Sarawak. Coastal erosion is one of the significant problems experienced in Malaysia, especially in Sarawak, causing damage to infrastructure and the environment too. The Department of Irrigation and Drainage Management supply engineering support and planning control for coastline protection. The condition of shoreline erosion is constantly being monitored and prevented by this department. Energy of the wave is a major factor that creates coastal erosion. Waves crash opposition to the shores and flush out the sediments along the coastline, causing erosion. Breakwaters are found as an effective method as it decreases the effects of storm surge and coastal erosion by absorbing wave energy during storm events. So as wave breaks on structure, their energy is reduced, calming waters on the shoreward side of the breakwater and reducing the direct impacts to the shoreline. Breakwaters will prevent most average waves striking the shore at their full force. These are some of the existing utilization of breakwater in Malaysia. They are breakwaters as Sungai Marang River mouth breakwaters at Kuantan Port, breakwater restoration and Haji Durrani. The break and these are two past researchers on breakwater. The breakwaters do not interfere with local waters. If damage occurs to the breakwaters, maintenance is very affordable and allows a community to have an ongoing benefit. These can be considered as the advantages of having breakwater, but sometimes as a disadvantage, it can be a threat to small vessel navigation. Now let's move on to the methodology. For methodology, there are 7 different steps. It is very important to identify the area of study as a design template will be created even though the geotechnical and environmental conditions differ according to the 7 different regions in Sarawak. Next, we have to adopt the coastline protection guidelines from Shoreline Protection Manual. After that, the selection of appropriate breakwater type should be done. These shorelines are mostly muddy flats or sandy beaches. Therefore, mound breakwaters will be a suitable structure. The selection also differed because of the wave conditions like wave climate or the wind statistics. There are several data that needs to be obtained in order to proceed with the calculation. The water depth, the beach slope, the design wave, allowable topping, and the structure layer are some of the parameters we need to obtain for the calculation of the breakwater. These data can be obtained through government websites and manuals, especially the Shoreline Protection Manual 1984. The calculation is done both manually and using the QPBOT calculator. The wave height, overtopping, forces exerted on the crown wall, settlement and bearing capacity are calculated using the manual method. The QBot calculator provides the calculations for design wave height, the size of recommended piece used for the construction of breakwater. Finally, a discussion and conclusion is held to get the recommended answers. The QBot calculator is highly reliable than the manual calculation as it is adaptive and fast. The calculation for the mount piece selection will be done to achieve the goal of designing breakwater design template which can be used in all 7 different regions of the Sarawak shoreline. The sustainability and the validation of the design will be evaluated from the obtained results in order to guarantee that the expected breakwater design will be able to preserve the Sarawak shoreline for a long time. Some of the references that were used are stated below. Thank you for listening, and you may post any questions you have.